Hey, fifth grade, it's Mrs. Seals back for our next science lab. So we are moving on to a new unit. We finished up physical properties, and now we are beginning a unit on energy. So we are going to start off this unit by talking about sound energy. So your target says I can explore the uses of energy, including sound. So let's review what is energy. You've been learning about energy since kindergarten. So hopefully you remember that energy is the ability to cause change or do work. In fifth grade, we're going to be learning about 5 forms of energy. And in order to help you remember those 5 forms, I have given you this acronym or this word MELTS. And each of those letters in the word MELTS stands for a different form of energy that we will be learning about in 5th grade. M is for mechanical energy, E is for electrical, L is for light, T is for thermal energy, which is the same thing as heat, and S is for sound energy, which is the one we're going to focus on today. So over the next 5 weeks, we're going to be talking about all of these different forms of energy. So sound energy is a form of energy that is produced by vibrations. A vibration is when something moves back and forth quickly. So hopefully you remember that all sounds are caused by a vibration. A vibration has to happen in order for a sound to occur. Another word that's very important when we're talking about sound energy is the word pitch. Hopefully you remember, maybe from music class, maybe from science last year, that pitch is how high or how low a sound is. It's not how loud or quiet. That's another sound word called volume. Pitch is high or low. Fast vibrations cause higher pitched sounds. Slow vibrations cause lower pitched sounds. Whoops. So here's an example of that. I'll come back to that in just a minute. I have these things here called tuning forks, which if you've been in the science lab in previous years, you have seen these. These aren't like forks that you eat with. These are tools that musicians or singers or people who play instruments use to help tune to the correct pitch. The bigger the tuning fork, the slower the vibration and the lower the pitch. The smaller the tuning fork, the faster the vibration and the higher the pitch. So I'm going to give you an example of a low pitch and a high pitch. Here's a low pitch. Ready? It sounds kind of high, but wait till you hear the high one. Here's the high pitch. Whoa, super duper high, right? So it's not loud and quiet, it's high and low. All right, we'll come back to that in just a minute. Let me go back to our PowerPoint. There we go. Okay, so fast vibrations, high pitch, slow vibrations, low pitch. How is sound used in our everyday lives? So I want you to pause, take a second, talk to somebody, or think to yourself. What are different ways we use sound in our everyday life, or why is it important to us? When you're done, come back and I'll show you the ones I came up with. So here are just a couple ways that we use sound. There are many, many more ways we use sound. These are just a few that I thought of. We use sound when we listen to music, to listen to our teacher or our classmates talk, when we hear birds chirping, when cars honk their horn, when we're listening to and watching TV, and when we're having a discussion with, our friends or our classmates or our teachers or our family members at home. When we want to communicate, we use sound. So we're going to explore sound energy today. The kids who are here in class with me are going to be rotating through some stations, and at each station they're going to be doing a quick little investigation with vibrations and pitch, and then writing about it. So this isn't really an experiment today. It's more of an exploration exploration, investigation, observation type science lab. Okay, so I'm just going to go through these quickly with you. The first one is it wants us to place a pinch of salt on top of a plastic wrapped cup and hit the tuning fork on the table and touch it to the plastic wrap and then watch what happens. So here's my plastic wrapped cup and I have some salt on top of it. I'm going to take my tuning fork and tap it on the table and then tap it to the plastic wrap. Whoa, did you see that? Did you notice how it looks like the salt is jumping or dancing? Let's try it again. Those are the vibrations. When I touch this to the table, it causes it to vibrate. And then those vibrations, when I touch it to the plastic wrap, cause the plastic wrap to vibrate. And it makes the salt look like it's kind of jumping or dancing. All right, that was just a little investigation to kind of explore vibration. The next one says, we're going to use a ruler for this one. We're going to let 8 centimeters of the ruler hang over the edge of the table and then hold the table end of the ruler with our hand and push the other end of the ruler down. Then we're going to repeat it with 15 centimeters. So you're watching the vibrations and listening to the pitch. Remember, we're investigating how vibrations and pitch are related. So here is 8 centimeters hanging off the table. And here is 15 centimeters hanging off the table. So here's what I noticed. When I have only 8 centimeters hanging off the table, it's much smaller. It's almost like the small tuning fork. The vibrations are much faster and the pitch is much higher. When I have 15 centimeters hanging off the table, it's almost like the large tuning fork. The vibrations are much slower and the pitch is lower. Let's do it one more time. Ready? Here's 8 centimeters. And here's 15 centimeters. Wow. Do you hear the difference? I really hear the difference. Okay, the next one, we're going to touch the center of our neck and say something and talk about what we feel. So I'm putting my hands here. La, 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 hello. I can feel something moving in my neck. Those are vibrations. Inside of our throat is something called our vocal cords. And whenever we talk or sing or hum or make any sort of noise, those vocal cords vibrate. They move back and forth very quickly. And what that does is it pushes the air or the sound wave out of our mouth, and then the sound wave travels through the air. Then when it gets to somebody's ear, the sound wave goes and hits their eardrum and causes their eardrum to vibrate. And then that's how they're able to hear sounds, is through those vibrations. Pretty cool, right? All right, 3 more investigations. The next one is with an index card and a comb, and it wants us to first move the index card across the comb slowly and then move it quickly. And then describe the differences in what you hear, which one made a high pitch, which one made a low pitch. So first I'm going to move it slowly. Ready? And then I'm going to move it quickly. Let's hear it one more time. Here's slow. Here's fast. Super fast. Okay, so hopefully you noticed, here's what I noticed. When I move it very slowly, that's causing slow vibrations, and so that's creating a lower pitched sound. When I move it faster, those vibrations, it's creating much faster vibrations, and that is creating a higher pitched sound. All right, the next one, oh, this one is tricky for Miss Seals. I don't know why I'm not so good at this. Maybe you'll be better. We need 2 bottles. One bottle is empty. One bottle has water in it. It's full. It wants us to blow first into the bottle that's empty. Ooh, pretty good, Miss Seals. Then I'm going to blow into the one that's full. This is the one that's hard for me. I don't know why. Ooh, I did it. Did you hear the difference in sound? Let's try it one more time. Here's the bottle that's empty. Here's the bottle that's full. Ooh, I notice if you blow a little bit harder, it's easier. I notice with the bottle that's empty, I'm getting a much lower pitch sound. With the bottle that's full, I'm getting a much higher pitch sound. I wonder, and here's maybe something you can investigate at home. I wonder if the pitch would change based on the water levels. Like if I filled this up more, I wonder if it would get even higher. And then if I took some out, I wonder if it would get lower depending on the water level. If you try that at home, let me know. Send me an email or a video or something and show me what you found out. And then the last investigation is with rubber bands. I have a thick rubber band. I have a thin rubber band. And it's going to be like these are guitar strings. I'm going to stretch it between my fingers. I'm going to pull on it. Okay, and then I'm going to do the same thing with the thin rubber band. Do you hear a difference? Let's try it one more time. Here's the thick one. Here's the thin one. I hear a difference. The thick rubber band is creating a lower pitch sound. It's vibrating slower. The thin rubber band is creating a higher pitch sound. It's vibrating faster. Whoa, pretty cool, right? Now, that was the end of our investigations, but the cool thing about this week is, with the exception of the tuning forks, you can probably do all of these at home if this is something you would like to do and if you have a parent's permission. All you need are an index card and a comb, a ruler, an empty bottle and a bottle with water, and a thick rubber band and a thin rubber band. That's all you need for these investigations. So if this is something that you do try at home, with the parent's permission, shoot me a video or a picture. My email address is amanda.seals@kilinisd.org. I would love to see what you find out through your sound exploration and investigation. Also, after this video, there is a short quiz for you in Schoology, so you can show me what you know about sound energy. I hope that you guys had fun. I hope that you enjoyed that. And I will see you next week when we talk about another form of energy. All right, bye guys, take care.